Welcome! We have a new large sunspot on the southeast quadrant of the Sun. It's from solar cycle 25 and it's interesting because it has a large penumbra. That's this greyish area around the main spot. This has been rare for solar cycle 25 regions so far. And it may be heralding the point where solar cycle 25 is about to take off and solar cycle 24 disappears. Some of you who are familiar with my channel will recall some of the predictions I've made about the transition between solar cycle 24 and solar cycle 25. I believe that solar minimum will be eventually settled on something like September or October of 2019. After minimum, solar cycle 24 regions will be in slow decline. There'll be fewer regions, they'll be weaker magnetically and shorter lived. There'll be no flares and very few CMEs from these regions. Meanwhile, solar cycle 25 will have new regions, more of them, they'll be stronger magnetically and longer lived. There'll be a sudden increase in activity called an onset within a year of minimum, and that'll be over a relatively short period of time, like 1 or 2 rotations. As a result, there'll be an increase in flare activity and CMEs, and there'll be a rapid rise to maximum over the next 3 to 4 years. This is a plot of the number of sunspot regions of solar cycle 24 and of solar cycle 25 over the last 18 months. Solar cycle 24 regions are shown in blue, and solar cycle 25 regions are shown in orange. I estimate that solar minimum was about at this point here in September or October of 2019. And you can see there's a distinct break in both curves at this point. Solar cycle 24 was going along quite nicely up until that point, but subsequently the slope of the curve drops. And in the exact reverse, solar cycle 25 was coming up quite slowly up prior to minimum, but once minimum was passed, it has taken off quite rapidly, and it overtook solar cycle 24 in the number of sunspot regions in May of 2020. And that difference is just getting larger and larger as time goes by. This is the last 6 days of this sunspot region rotating across the disk. As you can see in the top left, it actually appeared on the disk as a whole formed spot. And as it rotated across the disk, it hasn't really changed that much, although there has been a satellite spot that's appeared every now and then, as shown here with the blue arrow. To have a region like this generally means that it was once a much bigger and more dynamic region with more spots. So that was occurring on the back side of the Sun. And we're just seeing the end of this region. Now, the history of these sorts of sunspots, they tend to be very stable and last for a long time, but get slowly ripped apart by the differential rotation of the Sun. So this sunspot will travel across our disk, generally getting smaller and more broken up, and eventually disappear. I'm not sure it's going to make it all the way to the west limb of the Sun, but we'll see. Why is this sunspot region so interesting? Well, first of all, as I've said before, it's a solar cycle 25 region. You can see this from the magnetogram shown here in the top right from the SDO HMI instrument. It has negative polarity leading, that's the dark colour, and positive polarity trailing, the light colour, and that's in the southern hemisphere. And when that is the case, you have a solar cycle 25 region. It's a large spot, about the size of the Earth, with a large penumbra. But this is a mature spot, so probably it was once a much larger region with more sunspots when it was on the backside of the Sun. And so possibly there were even flares associated with this region, although we can't confirm that. So this is a mature region and is in a fairly stable situation. It's not growing or decaying, although there are at odd times a single satellite spot trailing behind the sunspot, as I showed before. We can ask the question, when did this region form? To do that, we're going to need to use the information from 2 different spacecraft. First, the Solar Dynamics Observatory, which is in orbit around the Earth, and second, from the Stereo A instrument, which is parked over the east limb of the Sun. So you can see part way around the back of the Sun. So combining these two, we can actually figure out when we first saw the region, so that will give you a chance to tell you how long the region has been alive, and also from SDO, was there a sunspot in that region when this particular latitude and longitude rotated off the disk. So from stereo A we get this picture, and the first indication that this region was there was on the 14th of July. So that would be in the 171 angstrom channel. So we look at the same channel for SDO, and the first time it saw it was on the 19th, and it didn't see a sunspot rotate off the disk several weeks ago, so therefore we can put an upper limit on the length of the thing. So from the stereo A and SDO data currently, we could say the region is at least 13 days old so far. And from the fact that there wasn't a sunspot on that location on the last rotation, we could say it's less than 20 days old so far, because it's not a returning region. So we can ask how this region is evolving, and to do that we're going to look at some videos. We're going to start with a video from stereo A when this region was on the backside of the Sun, and to show that the region was in fact at least a couple of weeks old. Then we're going to do an HMI visible light so you can see the sunspot, and then compare that with the magnetogram. As you can see, over the last 7 days, the X-ray flux from the GOES satellite has been rising slowly. It's gone up by about a factor of 3 in those 7 days. There have been odd little flares, in fact including one B flare, but in the last day or so the X-ray flux has increased tremendously, and so that seems to be indicating that something is going on. Is this region growing? But we've just seen from the video that it seems to be relatively stable. Something else has to be going on to be reducing this. And the answer is there's another region coming onto the Sun, this time in the northern hemisphere. You can see that region appearing over the northeast limb of the Sun in the SDO 171 angstrom picture in the right hand side of this frame. You can see that there are very large loops going very high into the corona. So this implies it's a large active region with probably large spots. We can go back to the stereo and see whether it saw this region before, and it has. If you go back to the 22nd of July, you can see that region in the northeast corner of that image, shown here with the white arrow. So this is yet another long-lived region that will probably be a new cycle region, a solar cycle 25 region, because of its high latitude. And in a couple of days, when those sunspots rotate onto the disk, we'll be able to see how complex it is and whether it's likely to give us any flares. With the rate that the X-ray background is increasing, there's a possibility that not only we will get some B flares from this, but we could even get a C flare. So what's my forecast for the coming months? It's pretty much as it's been before. Region 2767 will likely decay away as it slowly crosses the disk. It may not even reach the west limb before it is torn apart by differential rotation of the Sun. The new region is the solar cycle 25 region as well. That will be at high latitude. It should have one or more large spots. It may produce C flares if this X-ray background continues to rise in the way it is currently. Solar cycle 24 from this point on will decay away rapidly. Solar cycle 25 will intensify over the next few months, crushing the dreams of those wishing for a grand solar minimum, I'm afraid. So stay safe, and until next time, Goodbye.